Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 9, Lesson 5 on algebra and angles. Now we've already done quite a bit of work in our previous lessons where algebra and geometry have kind of mixed together, if you will. Today's lesson is just simply devoted to that. So we're not really learning any new geometry nor any new algebra. We're just going to be putting the two together and using geometry to set up algebraic equations, right, and solving them then to solve geometry problems, all right? So let's get right into it in the first exercise. Now, the tools of algebra are often used to solve geometry problems, especially when there's some kind of relationship between two angles, right? And we've seen a lot of relationships, right? We've seen adjacent angles, we've seen complementary angles, we've seen vertical angles, we've seen supplementary angles. So we've seen a lot of angle relationships, and really, your focus will be what relationship exists between the two angles and how can I use it to set up and then solve an equation, all right? So let's get into it in the first exercise right away. In the diagram below, points A, B, and C lie on a line. Ray BD is drawn such that the measure of angle ABD is 5x minus 2 and measure of angle CBD is 2x. Letter A, what is the relationship between the two angles? All right, so we just named 4 different types of relationships that two angles can have. Pause the video now and tell me which relationship relates these two angles together. All right, well, there's many different ways to say it. Now, one thing you could have said is that they're adjacent angles, and that certainly would have been true, but wouldn't have been overly helpful in terms of figuring anything out. What they definitely are is that they're supplementary. Or if you just said their measures add up to 180, or if you just said they add up to 180, that would be fine. When we were told that A, B, and C lie on a line, that's absolutely key, then that tells me that this angle, right, is a straight angle, right? So they are supplementary. I had to slow down there to think about how to spell the word supplementary, right? They add up to 180. Now, letter B, use this relationship to set up and solve for the value of x. All right, I'd like you to try to do that. Try to set up an equation and solve it for the value of x based on the fact that angle ABD and angle CBD add up to 180 degrees. Pause the video now and see what you can do. All right, well, it's pretty simple, right? The measure of ABD plus the measure of CBD must be 180, so I'm going to get 5x minus 2 plus 2x is equal to 180. Okay? Now I just need to solve this equation. So I'm going to combine some like terms. 5x plus 2x is 7x, right? The minus 2 just kind of hangs out. And now I have my classic two-step equation that I can solve, right? So what I'm going to do is I'm going to add 2 to both sides. All right, that's going to give me 7x is equal to 182. Then I'm going to run out of room. So I'm going to come up here. I'm going to get my little division by 7 in here. That's a little bit tricky, and then my board's going to kind of go crazy on me. There we go. Maybe I have to come over here and do 182 divided by 7, and that's going to be 2. 14, 42, 6, 42, 0. So it looks like x is 26. All right. And finally, right, I want to find the measure of both angles. I actually want to know what they are. What is their degree measure? Well, pause the video now and see if you can figure out what the degree measure of both angles is. Well, the measure of angle ABD is 5 times x minus 2, right? So the measure of angle ABD is 5x minus 2, but since we now know what x is, we just substitute it in. Now I might have to, on the side of my paper, do 26 times 5, right, and get 30, right, 13, right? So that's going to be 130 minus 2. So the measure of angle ABD is 128 degrees. The next one's going to be easier. The measure of angle CBD is simply 2x, which is 2 times 26, and that's 52 degrees. All right. Now, a wonderful check on this entire problem, by the way, is now seeing if 128 plus 52 is in fact equal to 180. And it is. You know, you don't need to see me do that addition, but it's a great check to make sure that our final answers, based on the value of x that we solved for, does give us two angles that have the relationship that we originally assumed that they did or figured out that they did in part A. All right, let's keep going with algebra and angles. Let's take a look. Now, setting up equations to model geometry problems can be more difficult when diagrams are not given. Having terminology mastered is really important, because if there's words that you don't know in the problem, right, and there's no diagram given, then it can be really tricky. So let's take a look at that kind of situation in exercise number 2. Two angles A and B are complementary. The measure of angle B is 3 less than twice the measure of angle A. Find the measures of both angles. Show how you arrive at your answer. All right, so I'd like you to pause the video right now and try to work through this problem, given, of course, the fact that the two angles are complementary is absolutely key here. So pause the video now and see if you can set this up and figure out the measure of both angles. All right, so here we go. First off, what does it mean for these two angles to be complementary? Well, that means, right, let me put it down here, that they're going to add to 90 degrees. All right, great. So the measure of angle A plus the measure of angle B is 90 degrees. Maybe I'll actually put that down right here. The measure of angle A plus the measure of angle B is 90 degrees. But that doesn't do much for me, right? I don't have x's, y's, whatever, right? So what else do I know? I know that the measure of angle B is 3 less than twice the measure of angle A. Notice, as we talked about earlier this year when we were solving word problems using algebra, that the measure of angle B depends on the measure of angle A, right? The measure of angle B is put in terms of the measure of angle A. So here's what I'm going to do. I'm going to say, let the measure of angle A be equal to x. Now, the measure of angle B, right, is 3 less than twice the measure of angle A. Well, there's twice the measure of angle A, and there's 3 less than twice the measure of angle A, right? The measure of angle B is 3 less than twice the measure of angle A. So if the measure of angle A is x, 2x is twice the measure of angle A, and 2x minus 3 is 3 less than twice the measure of angle A. And now I can take this, combine it with this, and set up an equation that I can solve. And here we go, right? I'm going to have x plus 2x minus 3 is equal to 90. Combine a couple terms here. That's going to be 3x minus 3 is equal to 90. I can add 3 to both sides. That's going to give me 3x is equal to 93. I can divide both sides by 3. And that's going to give me x is equal to 31. Now, keep in mind, the problem actually asks me to find the measure of both angles. This actually is the measure of one of the two angles, right? That's the measure of angle A. But I should actually state that formally, right? So the measure of angle A is 31 degrees. Now, the measure of angle B, though, is 2 times the measure of angle A minus 3, right? And that's going to be 62 minus 3. So the measure of angle B is going to be 59 degrees. There we are. And just like in the last problem, one great check on this problem is to now see whether this angle plus this angle makes them complementary, which it does, right? 59 plus 31 is equal to 90. So they're in fact complementary. But notice this one's a little bit trickier for 2 different reasons. One, no diagram given. So we must know that complementary means add to 90 degrees. The other piece, of course, that makes it challenging is just setting up the equation. And that whole, the measure of angle B is 3 less than twice the measure of angle A. That can make it quite challenging. Is it 3 minus 2x? Is it 3x minus 2, right? Really think about it. Always kind of start with the multiplication. All right, well, if measure of angle A is x, then twice the measure of angle A is 2x, and then it'd be 2x minus 3, right? And that's all it takes to get that equation set up, and then we have to solve it. Most of the time, solving the equation is easier than setting it up, but not always. Sometimes you'll have to recognize multiple geometric relationships in order to solve a problem using algebra. So let's take a look at another one where we actually are given a diagram. All right, exercise number 3. In the diagram below, points Q, N, and P lie on a straight line, that's important, with rays NM and NR drawn such that the measure of angle PNR equals 3n minus 14, the measure of angle MNP equals 4n plus 6, and the measure of angle MNR equals 118 degrees. Find the measure of angle QNM. Show how you found your answer. All right, so first things first, right? Make sure we know what angle we're solving for. QNM, that's going to be this angle, right? Ultimately, that's the one I'm looking for. All right, now, no great surprise, we're probably going to have to figure out the value of n in order to figure out that angle. All right, but how do we do that? Well, I'd like you to pause the video now and play around with the geometry in this problem, play around with everything that they've given you, and see if you can figure out how to set up and solve an equation to find the value of n. If you can do that, go ahead and find the value of n, and then see if you can use the value of n to somehow figure out the measure of the angle that they're asking us for. Pause the video now and take a few minutes to do this. All right, well, one thing I haven't brought in at all in my problem yet is the measure of angle MNR being 118 degrees. So where is MNR? Well, MNR is this angle. That angle is 118 degrees. And that's actually going to be the key to setting up and solving an equation, right? Because angle MNP, right, 4n plus 6, and angle PNR, these are two adjacent angles that when put together give us that 118 degree angle. So we can literally say 4n plus 6 plus 3n minus 14 is equal to 118. Those two angles, when added together, will give us that 118 degree angle. Now we want to combine some like terms over here. Now this one's a little bit more complicated. So let me do some rearranging here. Right? I'm going to change that subtraction by 14 into an addition of negative 14, just so that it's maybe a little bit easier to think about. I'm now going to say that 4n plus 3n is 7n. 6 plus negative 14 is negative 8, but I'll just write that as 7n minus 8 equals 18. All right, maybe I can, nope, can't pull that down by itself. Oh well. All right, so now I want to solve this equation. I'm going to add 8 to both sides. All right, that's going to be 7n is equal to 26. Something is going terribly wrong here. Oh, that's why, because that's not 18, that's 118. I'm like, that is just not making any sense to me, so that's 126. Divide both sides by 7. I seem to enjoy dividing by 7 in this particular lesson. So we're going to come over here, divide 126 by 7. That'll be 156, and that'll give us 18, right? Subtract, get 0, and n is equal to 18. Now, if the entire problem was just simply figure out the value of n, then we'd be done. N is equal to 18. But that's not the entire problem, right? I'm looking for the measure of angle QNM, this one. How do I find that? Well, there's probably a variety of ways to find it, right? One way to do it is to figure out the value or the measure of angle MNP, right? This angle. Now, why would I find this angle? Well, I would find this angle because this angle plus this angle is 180. So if I know the measure of angle MNP, I can just subtract it from 180 to find the one that I'm looking for. Now, to find the measure of angle MNP, I need to take my 18 and I need to substitute it into 4n plus 6. So let's do that maybe right down here. So the measure of angle MNP is going to be 4 times 18 plus 6. Maybe over here I've got to do 4 times 18, 2, 3, 72. Right? So that's going to be 72 plus 6, 78. Right? So this is 78 degrees. Right? So now the angle I actually am looking for, the only thing the problem actually asked me for, QNM, I can find by doing 180 minus 78, right? Let me just get rid of this. Takes much longer than I think it's going to. So the measure of angle QNM is 180 minus 78, which is 102 degrees. Sorry, that got a little bit down there at the bottom. Let me bring it up a bit so you can see it a bit better. But think about all the different things we had to do in that problem, right? The first thing we had to do was simply set up an equation and hopefully get our 118 right as opposed to 18, right? We had to set up an equation, right? We had to add these two together and set it equal to the angle that those two are, when put together, equal. We had to solve for n, and then we had to use the value of n to find an angle that wasn't even the one we were looking for. Once we knew that angle, we could subtract from 180 to find the one that was missing. All right, lots of steps there, right? So you have to really feel comfortable with your angle relationships and your algebra. Let's take a look at one final problem. All right, again, one where a diagram is given. Let's take a look at exercise number 4. In the diagram shown, lines A, B, and CD intersect at F, and ray FE is drawn. The measures of angle AFC and angle CFE are equal and are twice that of BFE. Use this information to find the measure of angle DFB. Show the work that leads to your answer. All right, so again, as always, make sure you know which angle you're looking for. I'm looking for angle DFB. DFB. So right now, I'm going to just put a little question mark there. Right? I like to say, keep your eye on the ball. Make sure you know what you're going for. Now, use the information in the problem, pause the video now, and see if you can figure out what that angle is. It's going to take you some multiple steps, just like before, but you'll eventually figure it out. Pause the video now and see what you can do. All right, now keep in mind what we're told. Angle AFC and CFE, here's AFC, here's CFE, those two have the same measure. So they're either both 30, they're both 60, they're both 55, they're both 90, whatever they are, right? They've got an equal measure. And they're both twice the measure of angle BFE. BFE. All right, now this is important, right? Both of these two measures are based on this particular angle here, all right? That's the one I want to have be x, right? So I'm going to let this be x. Now, if that angle is x and these two are equal and twice that value, then I could call this 2x and I could call this 2x. Now, don't get me wrong. You could call this x and call this x. And really, that's my first impulse because I'm told that they're equal. The problem is if this is x and this is x, then this would have to be 1/2 times x, or x divided by 2. If I don't have to bring fractions in, I'm not going to bring fractions in. So I would much rather call this x, this 2x, and this 2x because each of these angles is twice the measure of that one. Now, how can I set up an equation to solve for x? Well, I know that all three of these angles now must add up to 180. So I can say 2x plus 2x plus x is equal to 180. I can now combine like terms on the left-hand side. That'll be 5x's is equal to 180. Now I only have a one-step equation, pretty easy. I'm going to divide both sides by 5. Again, maybe over on my side of my paper, I do 180 divided by 5. I get 3, subtract 3, 6, 30, right, 0. And I get x equals 36 degrees. Okay. Remember, keep your eye on the ball. I'm still looking for this particular angle. Well, how do I get it? Well, one thing I might notice is that angle DFB, right, the one I'm looking for, is vertical to angle AFC, right? AFC and BFD or DFB, that's the way I called it, DFB, are vertical to each other. So if I can figure out this angle, then it's the same as this angle. But that angle is just twice x. So I can say that the measure of angle AFC is twice 36 degrees, which is 72 degrees. And that's the same as what I'm looking for. The measure of angle DFB is also 72 degrees because it is vertical. It is vertical to that one. And what we saw in the last lesson, vertical angles have the same measure. All right, and again, a lot of modeling here, right? X, 2x, 2x, recognizing that all three of those angles will add up to 180, using that to solve for x, then realizing the angle that we're looking for is vertical to that angle. And by the way, that's not the only way you could do it. You could also figure out this angle, add them together, subtract from 180, and get that angle. But again, that's also going to be 72. All right, let's wrap this up. Today, what we really practiced with was being able to look at geometric diagrams or even just geometric descriptions, right, and model what's going on using algebra, right? Once we've modeled the geometric relationship using algebra, we can then use our techniques, especially two-step equation solving techniques, to then solve the equation and figure out important geometric measurements, specifically the measures of angles. All right, so we'll do this a little bit more in future lessons and certainly a lot more in future courses. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.